Welcome to the latest Hear from the Experts webinar. This series is helping people better understand MS and provide tools to navigate their MS journey with more knowledge and confidence. Our intention is to help you learn more about the disease, research, wellness strategies, and much more. My name is Pamela Canellis. I'm the Assistant Vice President of Research at the MS Society, and I'm pleased to be your moderator today for this webinar focused on the latest breakthrough in MS research. I'm honored to be leading the research activities at the MS Society of Canada, where we support research that seeks to advance MS treatment and care, enhance the well-being of people living with MS, understand and halt disease progression, and prevent MS. Before we get started today with the presentation and our special guest speaker, I will go over a couple of housekeeping items. The microphones have been muted and will remain muted for the entirety of the presentation. The webinar is being recorded as well, keep in mind. And if you have a question, please type it in the chat box on the right of your screen, and we will try to get to as many questions as possible following the formal presentation. Please note that questions pertaining to specific personal situations cannot be answered in this type of venue, and we recommend contacting your personal MS healthcare team. Also, please note that the MS Society of Canada does not approve, endorse, or recommend any specific product, therapy, or service, but provides information to assist individuals in making their own decisions. Now, I'm very pleased to introduce to you Dr. Pamela Valentine, who is President and CEO of the MS Society of Canada. Under her leadership, the MS Society will continue to provide strong, community-based support and programs to Canadians affected by MS. At the same time, we will continue to fund the best research in the drive to find better treatment options for people living with MS and ultimately a cure. Over to you, Pam.
Dr. Alberto Ascario is one of the world's leading experts in neurological diseases. His work has taken him all over the world, from his initial study of medicine in Italy to practicing public health in Latin America and Africa before coming to Harvard in 1992. He is now looking into the causes of various neurological diseases, ranging from Parkinson's disease to ALS to multiple sclerosis. He recently led the long study which showed strong evidence that MS is a complication of an EBV infection, which has received a lot of attention both in the popular press and among his colleagues. But this is not all he's done in the MS world. He is also part of studies of vitamin D, both as a factor of MS generally and in African Americans, and investigations into factors created by and leading up to MS progression. We're thrilled to have Dr. Ascario here to talk with us today as an expert leading research which is both relevant to the daily lives of people living with MS and to the future, where we hope to see a world free of MS. Thank you so much, Dr. Ascario, for spending time today to speak with us.
Thank you, Pamela, for the nice introduction. It's my pleasure to be here and to talk to people who really care about MS. Okay, I think you should be able to see my slides at this time. So the topic of the presentation will be the Epstein-Barr virus as a causal factor in multiple sclerosis. I always like to introduce these beautiful drawings from Charcot that provided, already in the 1800s, an accurate description of the MS lesion in the brain and in the spinal cord. But the topic today is mostly what do we know about the causes of multiple sclerosis. Now, we know the pathology of MS is considered by most experts consistent with an autoimmune mechanism. But the role for infection has never been excluded. If you look at most review by expert neurologists who do research on MS, they will define the disease as an unknown etiology, meaning we don't really know what is causing it. Just a couple of words. Most of you are aware of the MS frequency that is the most common disabling neurological diseases in young adults. It has been estimated about 2.8 million people in the world live with MS, and this number is increasing. the incidence is higher in young adults and more common in women than in men. And the lifetime risk, I should say, in North American women, not only US, also Canada, is about 4 to 5. The lifetime risk between 4 and 5 per thousand. Let me get right into the matter that we are discussing today. So this slide is not a single study, just a composite of different investigations, and belong to what we knew, represent what we knew before the study that I will be discussing today. So if you look at this green column on the left, that represents the reference group. So we use that with a value of 1, indicating that that is our unit of measure, the risk of MS in people who are EBV positive but have no history of mononucleosis. So EBV for Epstein-Barr virus is a nearly ubiquitous virus, meaning that infects most of us. Now, over 95% of adults are infected with the Epstein-Barr virus. And in most people, it doesn't cause any problem. So you don't know that you have it because it's not giving you any symptoms or causing any disease. It has been known for a number of years, however, that Epstein-Barr virus can cause a number of diseases. The most common is mononucleosis. If you're not infected with EBV in early childhood and your EBV is therefore susceptible to infection when you are a teenager or a young adult, then if you get infected at that age, you have a high risk of developing mononucleosis, an acute febrile illness that can last a few weeks and can be pretty relatively severe. In the large majority of cases will resolve without complication or treatment, but is something more, say, than a common flu. Also, in rare situation, EBV can cause different type of neoplastic disease, specifically Burkitt lymphoma, Hodgkin lymphoma, and also nasopharyngeal carcinoma, and some type of gastric cancer. So it's not an entirely benign virus. The mechanism by which EBV causes these neoplastic diseases are being investigated, but EBV persists in the body. Once you get infected with EBV, the virus will remain in your B cells, which are a component of the immune system, for the rest of your life. And rarely some of these B cells are transformed by the virus and become neoplastic, so they cause lymphoma. And occasionally the virus can also infect epithelial cells and transform epithelial cell, and that is when it may result in nasopharyngeal carcinoma. So it's a virus that is benign, has been living with us for tens of thousands of years, co-evolved with human, but occasionally can cause complication. So the hypothesis we've been working on is that one of these complications is in fact multiple sclerosis. Why we generated this hypothesis, and I'm talking about thinking that happened about 20 or more years ago. Well, there were some clues. On one hand, we know that people who have history of mononucleosis, so a late-aged infection with EBV and symptoms of acute infection, tend to have a higher risk of developing MS, between 2 and 3-fold higher risk. And this was well established before our current investigation, particularly in studies done using the data from the Danish registry. The Danish MS registry demonstrated longitudinally that the history of mononucleosis is indeed a consistent and robust risk factor for developing MS. Now, what was the explanation for this association? Well, a common hypothesis was that this was due to a so-called high hygiene hypothesis. According to the hygiene hypothesis, individuals who escape infection in early childhood are individuals who are reared in a more sanitary environment. So they're not exposed to parasitic, viral, and bacterial infections as often as children in lower socioeconomic conditions or developing countries. And this lack of exposure to infection tend to prime the immune system toward more inflammatory responses. So individuals with mononucleosis belong to this high hygiene set. They escape EBV infection. EBV is transmitted by saliva, so by growing in a very hygienic environment with little salival exchanges with other children or adults, they escape infection, and they would be at high risk of mononucleosis due to the late age of EBV infection. And at the same time, independently, they are at high risk of MS because of the priming of the immune system. Now, this interpretation, if you believe in this interpretation, then you would expect that those individuals were EBV negative, who have never been infected with EBV. There are very few, but there are. Among adults, it's less than 5%. You would expect that this individual, who also come from a high hygienic childhood, they should also have a high risk of MS. But several studies suggested that, if anything, the risk of MS in individual EBV negative was very, very low. Now, the problem was that this column here in the middle, the low risk of MS in EBV negative individual, was not really demonstrated. It was inferred by the fact that virtually all individuals with MS are infected with EBV. So it's difficult to find a person with MS who is EBV negative. But we didn't know what comes first. So an alternative interpretation, there are two possible interpretations. One, that EBV is in fact causing MS and would explain this jump from this very low risk here to this very high risk here. It's a causal effect. But the alternative interpretation is that individuals with MS are more susceptible to EBV infection because of the dysregulation of their immune system. They're more likely to acquire EBV, and that is why they're less likely to be EBV negative. So we didn't have a longitudinal study that would tell us what comes first. Is it EBV coming first, or is it MS coming first? So that, in very simple terms, was the purpose of the current investigation. Conceptually, the study is very simple. So you start with large population of individuals. You need a very large population because most of them will be already infected with EBV, 95%. These are young adults, age of 18 or 19. 95% are already EBV positive, and only 5% are EBV negative. So what you want to do is to compare the risk of MS in those who are EBV positive with those who are EBV negative. In particular, see what happens in individuals who are EBV negative and become infected with EBV during the period of the study. So the study of this design is the closest you can get to a randomized trial. In a randomized trial, you would start with the same population and randomly assign some people to become infected with EBV and some people to remain EBV negative. Obviously, we cannot do this type of experiment in humans, so the best we can do is to do a longitudinal study and see who are the individuals who get infected and what the risk of MS is. As long as you control for important factors, a study like this can be very close to an experimental study. The important point is the comparability between individuals who are EBV negative and remain EBV negative and those who become infected with EBV, and we'll tell more about this in a moment. And the other important thing is to have some controls. And we use a control infection with a different virus, the cytomegalovirus, that is also transmitted by saliva, which is in a similar manner to EBV, to make sure that any result we could find with EBV was specific for the Epstein-Barr virus and not shared by other bugs, let's say. Sorry, this is my... I mentioned the importance of determining what comes first. So a slight complication here is that, as you may know, the diagnosis of MS and even the onset of the first neurological symptoms of MS do not always reflect the beginning of the pathological process. There is a so-called pre-symptomatic or prodromal phase. The disease process may start in a way that is not recognized by any clinical symptoms. There are two components. One is delay in recognizing that the symptoms are due to MS, but there is also a component due to the fact that some demyelinating lesion that are the beginning of the MS process may not be severe enough to cause symptoms, so they're fully asymptomatic. For this reason, we needed to find a way to identify the beginning of the disease process. And to do this, we measure serum level of neurofilament. Serum neurofilament is a protein that comes from the degeneration of neurons in the brain and the spinal cord. So in normal individuals, serum neurofilament are stable and low, but if someone develops MS, even in the preclinical phase, you start seeing an elevation of NFL. And that is the first sign that something is going wrong, let's say, in the brain. So we use the serum neurofilament as a marker of the very first of the actual initiation of the disease process. So summarizing, the purpose of the study were to determine whether EBV infection precedes the clinical onset of MS, whether it precedes the elevation of neurofilament light chain, and also to examine whether other viral infection that may occur at the same time or after EBV may trigger the onset of MS. So is the association specific for EBV, or is something that has more to do with the general susceptibility to infection? Now, the study conceptually is very simple. In practice, was very challenging because you need a very, very large population because, as I mentioned, individuals who are EBV negative are very few. You need repeated blood samples to determine the time of EBV infection. So we were able to, I think in the entire world, there is only one population where you could do this study, which is the active duty military personnel in the US. And the reason is that there is a serum repository. The Department of Defense maintains a serum repository in which they archive all the serum samples that are collected for HIV testing among the men and women in active military duty. So these archives now comprise over 60 million blood samples collected from 10 million individuals. And each individual contributes a blood sample on average every 2 years. So you can follow them over time and see when do they get infected with EBV. Further, MS is considered a medically disqualifying condition, meaning that if a young man or woman in active military duty is diagnosed with MS, in most cases, it will be a discharge for medical reasons. Most importantly, this is a very young population. You see the age recruitment, the typical age of recruitment in military service, age 18. So this is the distribution of the age at recruitment, and this is the distribution in the same population of the age at MS onset. In the world, there are not many longitudinal studies of young people. There are several cohorts, as you may know, to study cancer and cardiovascular disease. They typically recruit people in their 40s and 50s as the youngest and older, so they're not suitable for investigation of multiple sclerosis. This is a bit more technical slide, but just to briefly explain. So when you do a study like this, you cannot measure EBV and you cannot do EBV serology in 60 million blood samples, for the cost and all the complexity, of course. And also, most important, you don't need it. So what you do is what is called the nested case control study. This nested case control study will give the same result of measuring basically all the 60 million blood sample at a small fraction of the cost. You lose a little bit of precision, so the estimate will be slightly less accurate, but it's entirely valid. You would get the same result on average that you get from studying the entire population. It's like doing a survey. You don't need to survey 300 million Americans to find out something. You just get the sample, as long as your sample is representative. And that is what we did here. We could get all the MS cases were included in this population. All the MS cases that occur were included. But in terms of the healthy control, we took a representative sample, matched on age, sex, age, race, ethnicity, the date of blood collection, the military branch, meaning that this controlled in this study represent the entire study population conditional on this factor. So they're basically individuals of the same sex, age, race, ethnicity, etc., as the MS cases, to remove any confounding by these factors. EBV status was determined with the best available serology. ELISA is just one of the laboratory methods confirmed by Western blot. I will not go into the details of this. And these are the main findings of the study. So overall, we documented 801 cases of MS in this population. Of these, 766 happened in individuals who were already EBV positive at baseline. 34 happened in individuals who were EBV negative at baseline, but seroconverted during the follow-up of the study. And only one occurred in an individual who was EBV negative. Notably, all the 34 cases in the group that seroconverted initiated onset after the infection with Epstein-Barr virus. This is a way to look at this result in terms compared to what you would expect. So the blue line here on the left represents the rate of seroconversion for EBV among individuals who are EBV negative and didn't get MS. This represents the risk of becoming EBV positive in a general population of young adults in military service, and was very similar to what has been seen in other studies in university students, in colleges, and in military populations, about between 11 and 13% per year risk of acquiring EBV. But in individuals who got MS, you see this rate of conversion is much higher and is close to 100%. On the right, you have the comparable data using the cytomegalovirus. As you see, there is no association between the rate of CMV seroconversion and having MS, which show the specificity of the findings for EBV. Now, in terms of risk of MS, if we take the individual EBV negative as the reference group, the risk of getting MS in those who seroconverted was 32-fold higher than that of people who remain EBV negative. And in people who were already positive at baseline was 26-fold higher. Again, for comparison with CMV, you see there is no increased risk in MS associated with seroconversion or positivity for CMV. In fact, positivity for CMV at baseline was associated with a modest reduction in MS risk, possibly due to the fact that CMV infection modified the immune response to EBV infection. Now, a common concern when you do a study like this, it is an observational study. As I said in the beginning, you cannot do an experiment. So people who are in EBV negative and become EBV positive is not due to randomization. It's just to an experiment of nature that some people will encounter the virus and some people will not encounter the virus. So the major concern is confounding. Confounding refers to the possibility there is some unknown factor that causes EBV infection and causes MS. So if some factor causes both, then it could create a spurious association between EBV infection and MS. Now, what is not often appreciated is that to explain an increase in risk of 30-fold, this unknown factor, unknown confounder, would need to increase the risk of EBV infection by over 60-fold and increase the risk of MS by over 60-fold. And there is not only there is no known factor that could approximate this value, there is not even a conceivable hypothetical factors. The strongest factor for MS is the HLA-DRB15 allele that may increase the risk of MS of up to 3-fold, just to give you an example, very far from the 60-fold. Environmental risk factor like vitamin D deficiency and cigarette smoking may double the risk of MS. We don't really have a good candidate that will get even remotely close to this value. That is why we believe that confounding is not a plausible explanation for our finding. Now, the other possible explanation, perhaps a bit more subtle, is reverse causality. So, as I mentioned at the beginning, reverse causality refers to the situation in which having a mass increases the risk of becoming infected with EBV. So the way we addressed this was in two ways. One, by measuring the serum level of neurofilament light chain. So if MS was the cause of EBV infection, you would expect, at least in some cases, to see an NFL elevation preceding the infection with EBV, because the cause has to precede the effect. It's one of the only, solid criterion of causality that the cause comes first. So if MS is the cause of EBV infection, you would expect some sign of MS, and the earliest sign, the increase in neurofilament light chain to prevent the infection of EBV. And the second is that, if EBV infection is due to some immune dysregulation, you would expect some signal of this immune dysregulation. Why only EBV? Why only immune responses against the Epstein-Barr virus and not other viruses? So the results are shown here for NFL. So on the left, you have the within-person change in serum NFL level in individual who developed MS. As you can see, before EBV infection, if you take that as a point of reference, and around the time of EBV infection, this level are stable within this individual. It's only after EBV infection, that is in a sample collected after the person was already EBV positive, that you see an elevation. I think this proves in a pretty convincing and definitive manner that the sequence of event is first is EBV infection and then is NFL elevation. In individual without MS, again, you always need to have a control in whatever investigation you do. The level of NFL remain constant around time. This is before EBV infection, around the time of EBV infection, and after EBV infection. So it's a quite dramatic difference. Now, in terms of antibody against other viruses, we use a technique, a fairly novel technique called VirScan. Don't need to go through the detail of this rather complex cartoon, but basically with just a drop of serum, you can measure the antibody responses to over 100,000 peptides that cover all the protein synthesized by virtually all known human pathogenic viruses. So there are about 200 viruses in this list that are known that they can infect and cause disease in humans. Each of these viruses encode a certain number of protein, and each protein can be broken down into segments that are called peptide. So what is being measured by this technique is the antibody response against this over 100,000 peptide that give you an idea, is there any alteration in the general immune response against infection in this population of MS cases and controls. And the results are shown here. So this study was done in 30 individuals with MS and 30 closely matched controls, looking at sample before the onset of MS and after the onset of MS for the cases, and matched sample collected at the same time among control of the same age and ethnicity. So in orange here, you have the number of peptides that are enriched among the MS cases according to the different type of viruses. So in blue are those that are enriched in control, in orange are those that are enriched in the case. So you can see on the left here, virtually all peptides enriched in MS cases are peptides that come from proteins encoded by the Epstein-Barr virus. Most other peptides seem to have higher response in the control rather than the cases, with rare exception. The same in the post-onset sample. Again, you can see quite strikingly that the immune response is stronger in MS cases compared to control only for EBV peptides. So I'm quite confident in concluding based on this data that MS is a rare complication of EBV infection in the same way that, as I mentioned, other diseases like Burkitt lymphoma or nasopharyngeal carcinoma are rare complication of EBV. Now, we know that a common question is, well, EBV infects virtually everyone. Why only 1 in 200 or 300 people get multiple sclerosis? Well, there are different ways to address this question. I think that the most important answer is that that is true for most viral diseases. For example, poliomyelitis, before the vaccine against polio became available, the virus would infect virtually all the children in the United States, but only 1 in 400 would get paralytic disease. Did we ever figure out why that child and not the other 399? No, we didn't. We found a vaccine and we prevented polio. And this is true for West Nile encephalitis, for COVID, as you know, can be asymptomatic in many people and can be extremely severe in others. So that's the way viruses behave because of the interaction with the immune system of each individual, which is determined by complex factors that are different to capture. It's a combination of genetic factor, previous exposure to infections, the status of the immune system. So some individuals will have severe disease and some will not. And in the case of EBV, this is obvious for all the EBV-caused diseases like Burkitt lymphoma and Hodgkin and nasopharyngeal carcinoma. But there are factors that we know, if you're infected with EBV, may increase or decrease your risk of MS. One is obviously genetic predisposition. One may be the age of EBV infection, so the risk is higher if you're mononucleosis infected at an older age. Vitamin D deficiency or insufficiency may double the risk of MS. Tobacco smoking may also double the risk of MS. And obesity during adolescence, possibly because of low vitamin D, but maybe due to other factors. So what are the mechanisms? An important question, how does EBV cause MS? Well, the short answer, we don't know. So there are several hypotheses. This is a commentary in Science to our paper that suggests several group of mechanisms. One, the most popular is perhaps molecular mimicry. Molecular mimicry means that the immune system targeting EBV cross-react, the response against EBV cross-react with myelin or other antigen in our brain, meaning there are proteins in the brain that resemble, are seen by the immune system as similar to the EBV protein that the immune system is attacking. So there is a mistaken identification that these autoantigen are being attacked because they're mistaken for EBV viral antigen. There is a possibility of B-cell transformation. EBV is an oncogenic virus, so it also activate the B-cells, make this B-cell less resistant to the apoptotic signal and the regulatory signal. In favor of this hypothesis is the fact that, as you know, the anti-CD20 drugs that deplete the B cell from the circulations, which by depleting the B cell, they also deplete the Epstein-Barr virus from the bloodstream, are among the most effective treatment available. So this is one possibility. The third is possibility of a CNS tropism, meaning that EBV-infected B cells are more likely to invade the CNS, the brain. And if the virus reactivates in the brain, you can see how it can cause a pretty damaging immune response inside the brain. So the immune system attack the virus, but cause collateral damage, let's say, like inaccurate bombing that will damage the structure around the specific target. In four, it's important, other mechanisms, meaning there is no certainty. I think there is certainty that EBV is causing MS. There is no certainty on the mechanism. This is just to show that the virus is very sort of smart, so to say, it synthesizes two proteins that in some sense are misleading for the B cell, make a B cell look like a B cell that recognizes antigen. So normally a B cell as a receptor here would recognize the B cell receptor, would recognize a certain antigen. So each B cell has its own specific receptor, and there is a co-stimulatory molecule, and the recognition of the antigen and the co-stimulator will activate some downstream, a cascade of downstream event. Now, the virus synthesizes two protein, LMP1, LMP2, that activate this downstream cascade in the absence of a functional B cell receptor or engagement of CD40. So that is the trick, let's say, by which the virus survive in B cells. Now, in terms again of mechanism, several factors suggest the immune response to EBV. We don't know the exact mechanism, but the immune response to EBV is likely to have a key role because the MS is not increased by immunosuppression. The viral load in peripheral blood is only modestly elevated. It's not overwhelming EBV infection. There is strong association with antibody titers against the Epstein-Barr nuclear antigen, one of the viral protein, and the number of infected B cells is quite small, even in MS. Now, I think what are the implications of the current study? Well, I think the most important implication, the possibility of prevention. So in EBV negative individual, a vaccine that confers sterile immunity, so that prevent EBV infection, almost certainly would prevent MS almost entirely. Now, a vaccine that does not prevent EBV infection, but only prevent mononucleosis, that is modify the response to infection. In everyday now example is the vaccine against COVID. The vaccine against COVID, in most cases, does not really prevent infection, but reduce the severity of the disease. So a vaccine against EBV that has a similar effect, prevent the mononucleosis, reduce the severity of infection, but not infection itself, is likely to reduce MS risk, but there is less certainty on this point. Now, most individuals are EBV positive at the age of 18. So the question is, can we give a vaccine to individuals who are EBV positive? And I believe so. We have the example of the herpes zoster vaccine that is given to people who are already infected with the herpes zoster virus to prevent shingles, which is a reactivation of the virus. So it's conceivable that a vaccine could be given to EBV positive individuals to modify the immune response to EBV, to prevent EBV reactivation and thus reduce the risk of MS. Now, for many of you, the interest will be, what about individuals who have MS? Is there potential for a therapeutic vaccine? And in theory, it is possible, because if MS is caused by the immune response to EBV, a vaccine that modified this immune response could modify the course of MS. So I'm sort of being a bit redundant here, but just to make it, more clear and to finish, the key message for people with MS, and this referring part of the question that I received before the talk. So you don't need to do an EBV test. You're almost certainly EBV positive. I could say certainly, maybe 1 in 1,000 people with MS will be EBV negative. And even if the test turned out to be negative, in many cases will be a false negative. Even if it's not, doesn't change anything about the treatment that you would receive. So you are EBV. If you have MS, you are EBV positive. There are no antivirals or other approved treatment at this time for EBV infection in individuals with MS. In theory, it's possible that antiviral that eliminate or suppress EBV reactivation in people with MS could have a beneficial effect. We are trying to investigate this. We have been trying to get funding to test some antiviral drug in people with MS. This is unfortunately years away. So I don't expect to see any breakthrough for the next several years in terms of antiviral treatment in people with MS. There is an ongoing trial of an EBV vaccine, but at this stage is recruiting only EBV negative individuals for prevention of mononucleosis. So belong to that category of vaccine that could reduce the risk of MS, but it seems unlikely will provide complete sterile immunity that will be completely preventing EBV infection. And as I mentioned before, so a therapeutic vaccine is in theory possible, but even for this one, we will have to take. It will take a few years before it will be available, because first the companies are working on EBV, on a vaccine to prevent the EBV infection and mononucleosis. Trying to move to the next slide. I have one more, I think, but it's not moving. Okay, thanks. Okay, what are the key messages for people who are at risk of MS, who don't have a risk of MS? First and most important, so your risk of MS is small, even if you had mononucleosis. So the lifetime risk, unless you have a strong family history, is still less than 1 in 100, even if you had a history of mononucleosis. So nobody should be alarmed, oh, I had mononucleosis, am I going to get MS? 99% you will not get MS. Again, there is no reason to do an EBV test. 95% of healthy adults are EBV positive, and there are no treatments. So whether you are EBV positive or negative doesn't really matter. If you're EBV negative, you could become EBV positive, but there is no practical way to prevent EBV infection. The virus is everywhere, and I'm not saying it is impossible. If you isolate yourself and you live alone and you don't have contact with anyone else, maybe you can prevent EBV infection, but that doesn't make any sense considering the low risk associated with EBV infection. And reiterating your importance of maintaining adequate vitamin D level. For if you have children, avoiding obesity in childhood and adolescents will help to reduce MS risk and avoid cigarette smoking. Possibly, we have a few results in the pipeline suggest that consumption of alpha-linolenic acid that is present in walnuts and flax seeds, among other food, seem to be associated with a lower risk of MS. Okay, just let me conclude here, just to acknowledge my collaborator. There are too many to mention, but particularly Sandy Munger, Shetel Bjornevik, and Mariana Cortez have been the key player in this last work. And of course, the US military, active duty military personnel, and our military collaboration at the Uniformed Service University of the Health Science, among many others. Thank you for listening, and happy to answer any question.
Great. Thank you so much, Professor Ascirio, for that informative presentation. We'll now begin the question and answer portion of our broadcast with some pre-submitted questions, and we'll also be taking questions from Facebook Live and the Zoom chat, so please feel free to add your questions to the chat. Professor, you provided so many answers already to a lot of the most pertinent questions. So you've done a lot of groundwork already. So I'll start with a hard question and probably summarizing your work. But based on your research findings, can we now say that EBV causes MS? And if not, what do we still need to know?
I believe so. I know there will be people who are not convinced, but that is true for any novel hypothesis. We have people questioning that smoking causes lung cancer or that HIV causes AIDS. So I think the evidence is quite definitive, and over time, I think it will be accepted by most, if not all, investigators.
Great. So maybe we're still getting a few questions on some of the pieces that you highlighted, but just to clarify, maybe just to summarize, what does this research mean in terms of ending MS and a cure? What could that look like in the future?
I think knowing the immediate impact is on research, right? And until now, EBV was at the margin of the research on multiple sclerosis. So most research was done ignoring the fact that MS is caused by EBV. So, and this is changing. So we received several questions, and we know several groups that now what can we do to find out the mechanism. Finding out the mechanism by which EBV causes MS will open the door to new treatment. So if we know that, for example, that the EBV reactivation in the brain is the leading cause of the pathology, then antivirals and or other molecules that target the virus will probably provide a better treatment than anti-CD20 that to deplete the virus, we deplete the B cells. So we're already depleting Epstein-Barr virus with rituximab and ocrelizumab. But to do that, we remove an entire component of the immune system that is critically important to protect against other infections. So we could target, be more specific, target the virus instead of targeting the immune system to provide a cure for MS. All this is very promising, but it will take time. Unfortunately, the reality is that it's very difficult to move fast in research involving human subjects.
And what we've learned through this COVID-19 pandemic is that vaccines can be produced quickly if there's a lot of energy around that and focus. In terms of a vaccine that could be, and the vaccine could be treated for those who do not have MS yet, and those who do, just to clarify. And then versus antivirals, do you see either of those paths as the time to get to the point of treatment or prevention in terms of those paths, or is it pursuing both of those actively?
Right, a vaccine to prevent MS is. In some sense, will probably come first because if you prevent EBV infection, you prevent not only MS but also mononucleosis and other diseases. And we know that Moderna, for example, is already doing this. There is an ongoing trial. Now, a vaccine to modify the course of MS is a bit more challenging because you need to fully understand which component of the immune response against EBV are those that are causing the damage in the mouse brain, right? Because you may know that there is some work done by a company, Atara. This was before the current study, using cytotoxic T cells to suppress EBV. So there is some experience there with, possibly promising result, but very preliminary results. So there is interest and there is a possibility, but this is a combination of science and economics. I cannot provide the answer. So where the balance will be, is there enough, rationale to invest? That is a decision beyond my,
Yeah, and do you think that EBV infection is associated with other autoimmune diseases? Has that been researched?
I think that there is strong evidence for lupus, systemic lupus, not for rheumatoid arthritis and other diseases, in my opinion. I know that EBV has been proposed as the cause of autoimmune diseases, but I don't see the same evidence that we have for MS, for a variety of other autoimmune conditions, with the possible exception of lupus.
Great. And in terms of, there is a question from the Zoom. How does this new evidence and knowledge connect with your previous discussion around the hygiene theory and MS around the world? Does that change that theory?
Well, it modified that theory in the sense that the part that remained, that high hygiene can indeed increase the risk of MS, but the way it increases the risk of MS is by delaying the aged EBV infection. So in other words, if you have to get EBV, and most of us will get EBV, you're better off being infected in early childhood. But it's very specific for EBV. There is no evidence that high hygiene, independently of EBV, has anything to do with risk of MS. If you're EBV negative, your risk of MS is virtually null, no matter how hygienic your environment. It's only if you're infected with EBV, then better you get it when you are 1 year old than when you are 15 years old.
Great. And I think we've covered a lot of the questions that have come in. You did a really great job of covering a lot of the pre-submitted questions in your talk. So I think that's great. Is there anything else that you'd like to add?
Yeah, well, I just want to mention, because this day the virus variant have become a popular topic, right? With the COVID, the Delta, Omicron, and blah, blah. Well, there could be variants in EBV also. So this is an area that would be interesting to investigate. Going back to the geography of MS and why MS is some common in some countries than others, it is possible. I don't have hard evidence, but I think it's an intriguing hypothesis. There are variants of EBV. We know there are variants of EBV, that some variants of EBV are more likely to cause MS than others, which would be an important discovery in terms of MS prevention in vaccine. We could target those variants of EBV that are more likely to cause MS.
And that's flagging some other issues in vaccine development too. There is one question that just came in, and I know this is probably close to your work. Should increased levels of vitamin D be given to children if their parents have MS, maybe aligned with risk factors and other risk factors given the EBV infection?
I believe so. I've been recommending, people, virtually all young adults should make sure they have adequate, children and young adults should make sure they have adequate vitamin D levels. Now, you can achieve adequate vitamin D level by judicious, the stress is there, sun exposures, dermatologists otherwise will, rightly, be worried about sun exposure being carcinogenic. So if you live in Canada and you're not in condition to travel to sunnier location, between October and March you produce very little vitamin D. So I think most people would benefit from taking vitamin D supplement during the winter in Canada.
Great. Well, with all of that information, I'd like to thank you kindly for all that. We've come to the end of our time for questions. So thank you very much, Professor Scirio. This has been an excellent conversation. We're so excited about this groundbreaking research. So thank you very much. Before we wrap up, I also want to highlight the fact that the MS Society does have vitamin D guidelines on our website. If you're interested, this can be shared. So we provide that to different groups, children and adults, to provide recommendations around that. Before we wrap up, we just want to remind you about the MS Knowledge Network, which is staffed by trained navigators who provide consistent quality information and support. You can connect by phone, email, or live chat through our MS Society website if you'd like to sign up for a monthly if you'd also like to receive more information, you can also sign up for a monthly e-newsletter, and an MS navigator can help you do that. When you receive the e-news, you're kept up to date on the latest MS research and treatments, the Society's programs and services, and fundraising and volunteer opportunities, personal stories from people affected by MS, and so much more, delivered right to your email inbox. We encourage you also to get involved in our program services and events and volunteer opportunities. These days, connecting with others is more important than ever. We also encourage you to visit wechallengems.ca to learn about how you can help raise funds which are needed to maintain our research commitments, advocacy initiatives, and programming to support those affected by MS. And very soon you'll receive a survey by email about today's webinar, and we encourage you to fill it out. All the information collected will let us know if today's discussion was valuable to you and what topics you would like to see covered in the future. It will only take a couple of minutes, and your feedback will go a long way to helping us planning for future educational sessions. Thank you for tuning in today. I enjoyed the discussion. I hope you did. Goodbye, everybody.